Hello everybody, Paul Sheriff here with Pluralsight. This module is your first unit tests. Now what we're going to do in this module is we're going to create a class and a method that we need to test. We're then going to create a unit test project, write some unit test stubs, and then write the unit tests themselves. So to get started, we're going to create a class library project with one class called FileProcess and one method that is going to check to see if a file exists. We'll then create a unit test project, same name, FileProcess, but add test on the end for the class name. Then we're going to have a few different methods we're going to write that are very descriptive, that tell us what we're checking for in that test. File name does exist. File name does not exist. File name null or empty, throws argument null exception. Very descriptive names. Here is our file exists method that accepts one parameter, which is a file name. We then check to make sure that we have a valid parameter that's been passed in, and if not, hey, we're going to throw an exception that says argument null exception for that particular argument, and then we're going to return a true or false based on whether or not that file exists. So step one of our getting started with unit testing is we try to think of as many tests as possible for the method that we're trying to create. Then just write method stubs for each test. Don't write the test itself, just write as many descriptive method names as you can think of. Put inside of there assert.inconclusive. The assert class is what we use with unit testing. Inconclusive simply indicates to us that no test has been written yet. It's kind of, think of it like a / to do that you might add as a comment in code that you have not yet written. Step 2, create a test for each method, create a test for each overload of a method, and make sure you write tests to cover all the else, if, switch, case, loop, all those different types of statements. Step 3, hey, do we have too many test methods? Well, if we do, hey, you know what? Maybe it's time to refactor that original method. Maybe break it down a little bit more. Step 4 then, let's go ahead and start running the tests and see all the inconclusive results as a clue that, oh, yeah, we still got to write all of those. And then finally, we write the tests themselves. These are the ones that really test out the functionality of the method that we're trying to test. We might refactor the original method for performance or make it clearer to read or something like that, and then we just simply keep repeating this process until all our test methods are working. Here is a sample of the test methods that we are going to write as method stubs. So you can see each one here, the test for a good file name, the test for a bad file name, or test if no file name at all was passed. And you can see inside of each one of these that we've got the assert.inconclusive. So these are just our method stubs. They're just a clue to us that these are the methods that we have to write. Let's create a class library project, create a unit test project, and write our stubs. I'm inside of Visual Studio. I'm using Visual Studio 2017. But everything I'm going to do here will work pretty much back to Visual Studio 2010. Let's go ahead and create a new project. As we mentioned, we're just going to build a class library here. And I'm going to call it My Classes. Once it creates this, I'm going to go ahead and rename this class 1 to simply File Process. Once we've renamed this to File Process, we can add our public bool file exists method that accepts a file name. Pretty simple. I know that I'm going to be using file IO, so I'm going to go ahead and bring in the system.io namespace. I'm then going to check to make sure that the file name has been filled in. And if it hasn't, I'm going to go ahead and throw a new argument null exception, and you pass in the name of the parameter to this particular argument. Otherwise, we simply return file.exists and pass in the file name parameter. There's our method. Just do a build just to make sure that everything is correct. Let's now go over to our solution, right mouse click and choose Add, New Project. Find the test templates, choose the unit test project. And if you remember, the old one was called My Classes. So this one, let's give it the same name, but add a suffix of test to the class name. Then instead of unit test 1, let's simply call it file process test. So again, we're just going to add test to the end of everything. So that keeps our naming standards kind of consistent. Now, a unit test is nothing more than a class that has methods. But they add these special attributes called test class and test method. These come from this namespace here, which is under the Microsoft Visual Studio Test Tools.Unit Testing. So once we have this renamed, we can now name our test to be whatever we want. File name does exist, for example, right? Okay. And then we use our assert class, which also comes from that same namespace, and we specify inconclusive. And again, this is kind of like doing, one of those comments that you might put into your code to do that says, hey, I need to write the unit test here. So that's what the assert.inconclusive does. Now that we have this, we can simply copy and do another one. File name does not exist. And another one would be file name null or empty throws argument null exception, right? Because we want to be able to test passing in an empty file name and getting that exception back. All right, so now we've got our stubs. We haven't done anything yet. But what we can do at this point is we can right mouse click and say Run Tests, or you can go to the Test menu and choose Run All Tests. It's going to build the solution. It'll bring up the Test Explorer window, as you see here, and show us all the tests that we have still yet to write. Just like there are best practices for coding your methods, there are also some best practices for writing unit tests. One of them is called AAA, which is arrange, so that means initialize your variables, act, invoke the method that you are testing, and then assert, which means verify the act, right? And verify the data or the whatever came back from the method that you're testing. So in practice, here's how we might write our file name does exists. We arrange by creating the variables we're going to need, the file process class and the Boolean that says this is what's returned from the method we're going to call. We then act. From call equals fp.fileExists, passing in a file name. And then we assert what we're expecting to be the correct result. So in this case, I was asserting that it's true, this value that came back from file exists. So we're asserting that the value in from call is true. Let's write the tests now and check out how we do our unit testing. Let's write our file name does exist test. Now for this, we need to access the file process class. Remember, we're down in this DLL, the My Classes test. We need to access the file process class up here in My Classes. So just like you would normally do, add a reference. Go to Projects and choose My Classes. So now your test project is referencing the method or the classes from the other DLL. Now we can say File Process, and we can fix it up by using the Using My Classes. FP equals a new file process. We know that we're going to get a Boolean back, so let's specify that. So we have now arranged. Let's now do the acting. fp.fileExists, and for this we can pass in some known file names. So I'm just going to make a known one right now. I know that under Windows there's regedit.exe, which I'm sure most of us developers are familiar with. So we have now arranged, and we've done our acting. The last thing is then to assert. And we're going to assert that the value we're getting back from our act is true. So this assert.isTrue. And as you can see inside of this assert class, there is a lot. There's isFalse, there's isNotNull, there's isNull, right? There's all sorts of different things that we can test. And we're going to take a look at a lot of these throughout this course. But for now, there's our first test. Let's go ahead and run this and see if it works. Look at this now in our Test Explorer window. We now have our pass test, right? So it passed the test. Great. We still have our skip tests here, right? Because we did not change all of those. When I'm located inside of the method and I just choose run test, it only runs the one test. If I'm outside of any method in the class itself and I say run tests, it now runs all of them. Let's now go down and write the file name does not exist method. Now for this, let's go ahead and it's very similar to what we had up here, so let's just go ahead and copy and paste, but then we'll put in a bad file name here. So bad file name .bad, just to make sure it's not there. Now this time we are assuming that what's coming back is a false value. So we're going to check to see, hey, we're expecting this to be false. We're asserting that it is false. Let's now run this one. And that one now passed. So we now have 2 passed tests and 1 skipped that we have not yet written yet, because that one we have to check for an exception. When you have a method that's going to throw an exception, we have to make sure that we handle that. And there's 2 different ways. One is to use the expected exception attribute, where you specify the type of exception that this method is going to throw, and that way we know that the test passed. The second way is to use a try-catch, just like you normally would when you're writing code. We typically use the expected exception, except when we're using data-driven tests, which we're going to cover a little bit later in this course. Let's take a look at handling exceptions. Let's write the code here now under file null or empty. Now it's going to be the same, file process. So that part's the same. But this time what we're going to do is just call the file exists and simply pass in a null argument, okay, or an empty string. Then we're going to add our expected exception here. And to this, we need to tell it the type of the exception we're expecting, which in this case is argument null exception. And that's it. Let's go ahead and run this and see if we've done everything correctly. This one now does pass the test, okay, because it did throw an argument null exception. Now, you can test all of these out as well. So if, let's say, you're writing your code and you want to just test things, you can actually walk through the code. So set a breakpoint just like you normally would. Right mouse click and choose Debug Tests. It will do a build, it will then start the unit test framework, and it will start running, and then you can just use your typical keys that you would normally do to step through the code, as you can see here. I'll go ahead and hit F5 and just let it finish out. Okay, and that's it. Pretty simple to debug a test as well. Now let's add one more here. I'm going to go ahead and copy and paste this into another one. Throws an argument. Then this one we're going to use try catch. So again, I'm going to now change this a little bit, where I'm now going to simply use a try catch to try all of this and catch the exception, just so you can see what that looks like. So here's our try, and inside of the try, it's going to be our file exists, just like we had before. But the catch block, we're going to do something a little different. We want to catch the argument null exception, right? We want to make sure that that's the one. And if so, the test was a success. So all you have to do in this case is simply do a return statement. And that will then exit just as normal. All right, and that tells the unit test framework that this test was successful. The other thing then, if we don't make it through that, if it does not return that, then we want to do an assert.fail and then give it a message. Call to file exists did not throw an argument null exception. There we go. So again, you would run this test and make sure that this one passes as well. So we can now run all tests, and we now see that all of them are successfully passing our criteria. So the reason we do this again is because let's say then later on down the line, somebody comes in and says, oh, I don't think we need that code anymore. And they comment it out, or worse, they delete it, right? If we now go back over here and we try to run all our tests again, what's going to happen? Well, yeah, some of these are going to fail. So then we know that, hey, we better change, something changed, and we better go now fix this thing up. And we can go look down here and you can see, messages. So this one actually tells us what went wrong because we wrote this message. Call to file exists did not throw an argument null exception. So hopefully from this, whoever changed that code would be able to figure out what went wrong. There you have it. 2 different ways to capture exceptions. Let's talk about code coverage. Now, have you covered all the code with your tests? So that basically is all code tested, and these tools will help you determine what else you need to test. These are tools that are built right into Visual Studio. Unfortunately, it's only in the Enterprise Edition though. So if you don't have that, you will have to get that. Okay? It should be in the TFS edition as well. But let's take a look at this code coverage window and see what it looks like. If you're running the Enterprise Edition, you can go to your test menu, and there's another menu called Analyze Code Coverage. And let's go ahead and analyze all tests. Now this is going to build and then run each test and then tell us what's basically covered and not covered. So you drill in and it shows you all the projects in this particular solution. We only want to focus on our DLL, not the test DLL. We don't care about that one. We're not testing the tests. We're simply testing ours. And it'll then drill in and show you the file process class here. Okay, so you can see right now we're 100% covered, right? We've covered everything. Okay. Now let's go ahead and put this back down here. And let's go ahead and go back in here. Now, if you remember I had commented this out, let's re-uncomment that, okay? And again, let's go ahead and analyze the code coverage. All right, so again, this shouldn't change much, right? Everything should just be here, okay? We can drill down into our little class hierarchy here and see. So everything still is covered 100%. Now let's do this though. Let's actually put these back to the assert.inconclusives. If you remember, that's what we did originally, right? So we'll change that for the file exists and the file name does not exist methods. Now let's go ahead and look at what our code coverage will look like. So it's running. There we go. As soon as this refreshes down here, you know that it's done. And now we can see that, hey, we're only 57% covered. We had covered the combination, so it determined that the combination of checking for a null or empty, that was covered. But it found out that we didn't cover the rest of the method, right? So it's saying that, hey, you didn't cover everything here. So that means we need to drill in, and if you double click down here on the file exists, it actually tells you what's good and what's not. Okay, so you can see the lighter color here, this one here, that's the stuff that got covered. Okay, and then the one down here is the one that did not get covered. So this one in kind of the more yellow. Now the colors may change depending on, what you have your colors set to, right? And you'll learn, kind of what each of these colors mean. But this is nice that it highlights everything for you so you know which code blocks that you need to cover. As we go along, you're going to write more and more methods. These numbers will change dramatically, right? So the code coverage will change as you go along. You just have to keep trying to get more towards 100% as you can. You may not be able to get 100% all the time, but you want to try to get there as much as you can. In this module, we created our first unit test project. We wrote our test stubs, and then we wrote our final test using the arrange, act, and assert methodology. We learned how to handle exceptions, and we took a look at the code coverage window. Coming up in the next module, we're going to take a look at avoiding hard coding and the test context object.